In today's class, we are going to talk about the storage classes and what are the storage ingestion options that uh, Amazon S3 offers. So we already saw that multiple storage options are provided by Amazon, the S3 file storage, and then the archival storage, and then the block level. So I just want to touch upon the topic of Amazon Glacier, the archival storage that Amazon provides, and it is for completely, if you have data which you are not using for a very long time, and if your data which you need to store for compliance reasons only, where you don't process anything and want to incur very, very less cost, then Glacier is the choice of storage it is going to be for you. And the only downside of using Glacier is you have to wait at least 3 to 5 hours of retrieval time whenever you are talking about Glacier. And the retrieval is, since there is a delay in retrieval, you cannot use it for any real-time scenario cases. And the plus side of it is you get it at a very, very cheap cost. It is like $0.01 per month. If you notice it, it is not per day, per gigabyte of storage, of transfer, all those things. It is per month. And it is pretty much very cheap. If you think of it, 123 terabytes per year for accessing your data all over the world, it's pretty cheap. And a lot of people use it for compliance reasons, and also a lot of people use it as a backup archive. You can directly send your backup to Glacier Cloud, and then you can use it as a backup destination also. That is also possible. The use cases are varying. You can use it absolutely whichever way you want. It is absolutely, there is no restrictions on this is the way you want to use it. So go ahead and try different ways of using Glacier. And since the cost is less, you should not be able to incur too much of charges here also. And whenever your customer asks for long-time archival storage, tell them Glacier is the choice of storage that they should be looking at. We also saw how to move it from in our account. We also put some lifecycle policies. Today, let us go and see whether those lifecycle policies have kicked in. If you remember, I have put it as 1 day from the object has been created. So yesterday, around the same time, we created the object. Probably it might have kicked in today, or it might kick in tomorrow, the lifecycle policies. So let's go ahead and check that when we are going to do the demos. Moving forward, when should you use S3 and when should you use Glacier? These are the two choices that you have when you are comparing these two storage classes. I think it is not refreshing. Let me go ahead and try to hit the refresh again. Okay, so these are when you are talking about when to use S3 and when to use Glacier. The first question that you are going to ask is what is the storage cost your client is willing to spend against what is the retrieval time that your client is willing to spend. So what is more important to you, your client, or what is more important to them when they are talking about storage? So based on that, you are going to recommend the appropriate storage for your clients. So that is one of the most important criteria of selection of storage classes. And if there is an in-between requirement, then you are going to recommend IA, standard IA, that is infrequent access or reduced redundancy storage. So if the choice is between real-time access and very, very infrequent long-term access, then it is between S3 and Glacier. So you choose the appropriate class of storage based on the client's requirements. You can see the different differences between the two storage groups, the 11 nines of durability against the 4 nines, and then the cost savings, and then the retrieval time, and it is great for backups. One is very, very good for backups, and one is good for doing everyday use cases. So you tell them, you discuss with your clients, and then talk to them and understand what exactly they are wanting, and then tell them this is the best storage for them and this is the cost. I will show you how to estimate cost in Amazon. That is an Amazon simple monthly calculator is there. I will show you a quick demo some other time. For now, you just remember that there is a very easy way to estimate your cost in Amazon on a per month basis, on a per region basis. I mean, per region, or as well as all the regions put together as well. So you don't have to guess the cost anymore. You just need to understand how the pricing strategy works and then try to model it correctly in the calculator, and it will show you the cost. It is not like on premises where some magic happens, some Excel sheet, and then the price is given to you after putting in the margins. It is all public available data. Whatever price that you see there will most probably will be the price you see in your bill after you have modeled correctly. Probably some taxes will be there. That is depending upon where you are using the services, and taxes will differ. So moving forward, data ingestion options. That is, how do I get data into my S3 cloud or AWS cloud? We touched upon this earlier. So to breeze through, a direct connect between your on-premise and your cloud, a VPN service will be VPN cable will be laid down, and then you can use the VPN. It is just like your internet bandwidth connection, but dedicated for you only. So you can send or receive data at 1 Mbps or a 10 gigabit, 1 Gbps or 10 gigabits per second. And then your Snowball, whenever you have a data requirement of 50 terabytes to 80 terabytes, then your Snowball makes a very good use case to be used. You raise a job, it is called a scheduled job in the portal. Amazon will ask you your address and they will send you something like this, a briefcase. You connect it to your account or your data center, copy all the data and send it back to them, and they will upload it in your cloud. So that is how Snowball works. And then there are some independent software vendors or third parties that will allow you to connect their data center and your data center in AWS. So in other words, you are transferring the responsibility of moving the data into cloud to somebody else on behalf of you, and then they will do that for you. And Snowball Edge, this is a very new service, that are new in the sense relatively new when compared to the other options. You upload it to an edge location, that is the briefcase will come to you, and then the briefcase will upload it to the nearest edge location, that is an CloudFront edge location or a point of presence edge location, and from there it will be moved to any other region that you wanted. So this is little costlier when compared to this. This will move directly to the target destination, but when you're talking about Snowball Edge, it moves to the nearest AWS location, and from there it moves to your target destination. So that's the difference, and there's a cost difference between those two. And finally, if you have a streaming data that is coming in, let us say you want to store all your Twitter feed for your corporate account, or you are launching a new product and then you want to manage the feedback for your product, then you can connect your Kinesis Firehose to your data stores. Your data store can be an S3 or a database or anything. So this is another very good option if you are having an incoming stream of data and very small in size. If you have a lot of movie files coming in, this will not help. This will not be the best way to do that. But if you have some small amount of data which is not periodic and it can spike anytime, then Kinesis is your best use case in that scenario. And we touched upon S3 acceleration. I will show that when you're talking about the performance optimization of S3, we will see how S3 transfer acceleration works. It's nothing but multi-part uploading. You just break the bigger file into smaller files and start multiple streams of upload. It's the same way of any batch management job is. If anybody has used a mass downloader or some other download software from the internet, they would know that there will be multiple streams running at the same time to reduce the download time. Think of this in the reverse way. You're breaking down your uploads and then doing multiple streams. Storage gateway, again, this connects your on-premise data center to your cloud by using an VM. Amazon provides you a VM, and then using that VM, you can store data in the cloud itself directly, or you can store or clone your on-premise data center to your cloud data center. So that way you can take a backup or move data, or both are different use cases. You use it as a destination for a backup, or you can extend your on-premise disks by using cloud-based disks. You don't provision the on-premise disks anymore because S3 or EBS volumes are automatically provisioned, and it scales faster. So on-premise VMs or servers can have cloud storage available to them. So in each of those cases, this is the important criteria. You don't have to remember these numbers, but just understand that there will be a small difference in the amount of data that you can transfer to them. That is, the upload rate will be different in each of those use cases. And depending upon your client's requirements, you need to choose the appropriate use case and then do that. So, and then after talking about this, there is another important service that Amazon has introduced, and it is called Snowmobile. And the Snowmobile is for new petabyte scale data movement option that you get. If you have more than 100 petabytes of storage that you want to move to the cloud, then you call Amazon, create a scheduled job, and they will send you a truck with full of disks. And then once you upload the data to the truck, and then the truck will drive down to the data center and then upload it to your destination. So it's also a very good service. And if you have a lot of information or data that you need to send it to the AWS data center, then you can use this option. So let us move forward. And okay, this is what I was talking about. This is just a more detailed understanding of how it happens. You first create a job. In the job, you tell Amazon that what you want to do, where is your location, and Amazon will accept the job and give you a timeline of when the disk will be shipped to you. Once you get the disk, once it is shipped to you, then it is with the customer. And once it is with the customer, connect the appliance to your network and set the IP address and do all the process that the manifest allows you to do. I mean, all the data will be shown here on what you need to do. And once you connect all the data, then you tell Amazon that you want to send the data back to them. So it is again, it becomes Amazon's responsibility. That is, the transfer from your data center to the cloud becomes Amazon's responsibility. You don't have to worry about the data that is being unsecurely shipped or anything. It completely is within Amazon logistics. And then once it is at Amazon, Amazon will update your job that you created in the beginning with the status, and your data will be in either S3 or whatever destination you chose. These options are all used on the Snowball, Snowmobile, Snowball Edge. These are all new services, and very few people are starting to use it. It is quite possible that some of you might not ever use these options, but it is good to know that you all these options that are available, because sometimes interviewer asks you the question of how can you move data to the cloud. So you speak about some of the features that we saw in the previous slide, and that should be enough to get you over that question. And in real time also, some people use Direct Connect, some people use Snowball, some people use ISVs. They give it to the third parties to move the data. So you might not work on this directly, but all those options are used in a varying degrees in real time. Finally, moving on to the topic that I wanted to discuss on performance optimizations for S3. There are at least 5 different options for us. We have touched upon all of them briefly when we are doing the demos, but let me group together logically and show that to you guys. So S3 transfer acceleration is one of the options. So you can choose the change your endpoint, not your code. Don't try to optimize your code to upload more and more data faster. What it means is, as you can see here from your desktop or server that you're uploading, do not upload it directly to your bucket here. What you do is you do it to your edge location, and then from the edge location, Amazon will transfer it to the S3 target S3 bucket, and this movement is done by Amazon itself. So it is highly throughput optimized, and you don't have to worry about how much data I'm transferring. You can do a speed test, try the S3.speed test, and the speed test will typically show you something like this. I'm not able to change my screen. Yeah, the speed test will show you something like this for different locations. You can see the different regions at the bottom and the different speeds that you can achieve when you use the public internet and the S3 transfer acceleration. And it is also noticed that the longer the distance and longer the file, more the benefit, because Amazon is going to move the file between their data centers using their own internal technologies. So if you are going to move it from a longer distance, say for example from India, I'm going to send a lot of files to United States, which is across the globe, which is half the globe for me. It is like directly other side. So that is a very long distance, the maximum we can go for. And if I'm going to send a lot of files, then there are more benefit for me to use transfer acceleration. So if you're depending upon, once again, it's a use case by use case. We don't have to try to do all these kind of things for a small file set of 1 GB or 5 GB. But if you want to do 100 or 500 or 1 TB, then definitely you should look at these options for performance optimization of your upload. Next is faster uploads. We spoke about this parallel puts here. As you can see at the top, you have the original object. And what you do is typically in your software, you make it delineated into smaller linear parts, and then you upload into multiple streams. As you can see, there are 4 parts that has been defined, and each of the 4 parts are having 3 blocks to upload. And then since there are 4 streams going on at the same time, your finalized object goes faster into the cloud. So this is something a software defined, software driven way of increasing your uploads. Mostly your application teams or coders or developers will be involved in doing this, but this is one other way to increase your upload speed. And guys, don't forget it or misunderstand it or give this topic a miss, because uploading data is one of the biggest pain points that customers are facing right now, and uploading it with consistency is another pain point. So these are all the options that you get for uploading it. The first one is transfer acceleration, and the second one is parallel puts. That is, parallelly I'm making multiple puts into the S3 bucket. Next is likewise faster download. Now you're going to do parallel gets. What happens is you have a range when you're making a HTTP request, you can request for a particular range of bytes. Say in your first request, you range bytes 0 to 9, and then in your another request, you can request for bytes 9 to 19 or 18. So like this, you can make your gets also in parallel, so that you can download data faster from your S3 bucket. So that is also possible for you to do. So another recommendation, do parallel gets, and once you have parallel gets, you are able to get the file faster. If that is also not possible, you don't want to optimize your code for doing all these things, then you do content distribution by using Amazon CloudFront. We will see a demo later today how to use Amazon CloudFront, and it caches the object at the edge, and you have a lower data transfer to the end user, lower latency data transfer to the end user. So that is another option, parallel gets. And finally, this is a very good exam-based question, distributing your key names. Let us say you have a very high transaction processing system and you are storing a lot of files. Let us say that you are constantly exceeding 100 transactions per second on a bucket. Avoid starting with a date. Don't do something like this. If you have a bucket and then you have a date followed by the image name dot extension, don't do like this. You don't want a serial number here. What happens when you do this is this. You have a lot of partitions. Amazon stores data and partitions, and if you store it in serial number, all the partitions are also stored, all the sequential keys are stored in the same partition. So all the endpoints, say a lot of mobiles are trying to access the data, then all of them will be hitting it sequentially in the same partition, because that is the way Amazon stores the data in S3. Sequential number or keys, that is, as it is called, will be stored in the same partition. So instead, since all the people are accessing the same partition, their I/O and their latency is going to increase considerably and slowing down the performance or experience for all those people. Think of it, a mobile app is trying to fetch some data, that is a browsing e-commerce portal, and all the images for a particular brand or a particular object or a particular discounted object is stored in one partition, which is sequentially named. Then the browsing experience for all the people accessing that partition or that product will be very, very bad, and they might quit browsing also or move to another platform. So don't do this, don't use sequential numbers, do something like this and randomness to the beginning of the key names. So if you have a bucket and then add some random characters in the beginning of the bucket, and then you will have the bucket name. So what happens when you do this is your keys or your objects are distributed to multiple partitions, and all the endpoints will be accessing different partitions. So this way you can improve the performance of your S3 bucket by distributing your key names. In simple terms, randomize the key names, at least in the beginning part of it, and then have your file name after that. So this way your performance is improved. Finally, sometimes you want to make a list of all the objects in your S3 account. Whenever you have millions of objects, it is not a very easy task to do. And only when you have a list of objects, you can do some post processing on top of it. This is all useful for very big web scale companies who wants to do data processing using an S3 as a destination bucket. So don't do it yourself. Don't do there are APKs available using Python, Java, .NET, and all those things. Do not try to build the inventory by yourself. Amazon has their own built-in mechanism to build an inventory, and they will save it as a CSV flat file output in a destination bucket. And you can configure it to run daily, weekly, any way you want it. And the price is also not much. As you can see here at the bottom, it is about $0.25 per million objects. So even if you have 10 million, let us say, that is going to be $0.025 per dollars per for 10 million objects. So it's pretty cheap and it is fast as well. So use the S3 inventory option to make a list of files, and it gives a metadata also, it gives the tags, it gives the type of objects, size, and all those kind of things. So use this when you want to build a list or when your customer wants to build a list. And finally, if you want to query something directly on S3, there is a new service Amazon has launched called Amazon Athena. There is no loading of data, there is no servers, it supports all the different file formats, and you can query it directly using an Amazon Athena console or a JDBC driver. And the cost is also not much, it is $5 per terabyte. So if you divide 5 by 1024, so even for 1 gigabyte, you are talking about less than a dollar, way less than a dollar, few cents for even 1 gigabyte of data scanned. So if your customer wants to store data and try to query it, you can use Amazon Athena and S3, or you can put it into Glacier and use something like a Redshift also, that is also possible. But if you want to query directly on S3, Athena is your only option, and it is also cheap. So to summarize, these are the best practices: faster uploads using S3 transfer acceleration, that is one of your options, and then faster upload for larger files by using multi-part uploads, that is another option that you can make use of. Then you can have optimized get by using the range get option of get, or you can use CloudFront, that is also possible. And randomize your keys. If you randomize your keys, then your high transaction processing workload will improve or behave very nicely, and your customers will be happy. And use the list option or inventory option that Amazon itself provides to make your inventory faster and to do some post processing. You can also do SQL query directly on S3 using Amazon Athena. It uses the basic SQL format, which people who are familiar with SQL format can go ahead and try to use that. And remember that Athena is not a free service. So if you're going to query your data, whether it is 1 KB or 10 KB, you will be charged certain dollars for that. So if you are familiar, if you know how to do SQL queries, upload some 10 rows or 10 records, try to run a query, you should be able to get an answer. It is very straightforward. The console is typical. Any SQL developer should be familiar with the console here, and they should be able to use that. Just a point of caution, it is not a free service, and it is a new service, and not a lot of people have started using it. So you don't have to really be concerned about working on this right away when you start your career. But going forward in the next few months or 1 year, this might be becoming very popular because it uses an Hadoop Presto engine at the back end, and it is very fast. You can go ahead and Google that in the internet. So content delivery network, CDNs. So let us quickly see how to set up, what is a CDN and how to set it up. Content delivery network, I have spoken about this many times. If you have a S3 bucket and you want to share media to a lot of people, which is not changing often, then edge locations are fantastic. You can sit in India and distribute your movie or your homemade video or your own homemade music album all over the globe by using edge locations without setting any hardware. All you have to do is put it in an S3 bucket and configure a CloudFront distribution for the on top of that bucket, and Amazon takes care of distributing the content all over the globe. And the latency is optimized for the destination, and you can choose to distribute where you want it. You can choose to restrict wherever you want to restrict it. Say, for example, you don't want to launch your music album in um, Europe, you can do that. If you don't want to launch it in China, you can do that. You can have geo-based filters, you can have proxying, you can have streaming media. All those kind of options are possible. And since the cost is also optimized, there is a cost associated with using CloudFront locations. You are being charged for the caching cost and the amount of data transferred out of the edge location to the endpoint. So remember that there is a small cost associated with this service as well. So there are different service components associated with CloudFront distributions. Distribution is a collective name of what you're trying to distribute. It can be a static file or it can be a dynamic file. For example, RTMP is the format for streaming videos and changing content over the internet. And you can choose to do both, either static or dynamic. So we will see one of those examples when we are doing the demo, and that is what is called as a distribution. When I'm talking about origins, what I'm talking is here is what is my source of my content, whether it is an S3 bucket or is an EC2 location or is it some other location my data is going to come from. And behaviors, so when I talk about behaviors, you can choose how your CloudFront distribution works, what kind of request is coming from, either it is a get request, put request, or you're talking about a delete request. All those kind of things, you can change the behavior of your CloudFront distribution based on the incoming request, and you have more fine-grained access. We have more data on each of them. Let us quickly go over them. Let us look at it here this way. So I spoke about distributions. So it is an unique CloudFront URL. You will get a unique CloudFront URL, something like abc123.cloudfront.net for each distribution that you get. And it supports HTTP and HTTPS. You can use Amazon certificates or your own certificates. That is also possible. And you can have configuration specific tags. Using origins and behaviors, you can decide how your CloudFront distribution is going to behave. And the answer to a question that yesterday's gentleman asked, you can have a CNAME for your CloudFront distribution and point it to your Route 53. What it means is you don't want to give this ugly abc.cloudfront.net to your clients. You can have your corporate domain name www.abc.com point to this CloudFront domain, and automatically they will be redirected to the correct destination. So you can hide this big CloudFront destination using your Route 53 also. That is also possible. Origins, as I said, let us say this is your CloudFront distribution. You can pick up the source files from either an S3 bucket or an EC2 instance or from an Elastic load balancing application, or you can configure a custom origin. It can be your on-premise data center, or it can be a third-party content distribution network or anything. So in other words, CloudFront can pick up from multiple origins and distribute it all across the globe. And you can have proxying connections or full or half SSL bridge, that in other words where you want to drop your SSLs, or you can use content restriction using origin access identities. In other words, you allow only certain people to access it. So that is what is origins is all about. Edge locations, this is a very interesting architecture in my opinion. Earlier, this is how it was. If let us say that your origin is an S3 bucket or an EC2 instance, so it was directly copied to multiple edge locations like this. But Amazon found out there's a performance improvements if they have a regional edge caches. What it means is Let us say my data is in Mumbai region here, and I want to distribute it to Europe. What they do is they have a regional edge cache. They distribute it to Europe, and from within Europe, they distribute it to UK, France, and Germany to regional edge locations. So likewise, in the United States, they will have one regional edge cache, and from there they will distribute it to East Coast, West Coast, and Central. So this way, your data is having a highly performant architecture in the background, and your edge locations are in multiple places. It is fault tolerant as well. So one edge location is unavailable, the data is rerouted, and it is going to fetch the data from your regional edge caches. And the cost of distributing for you also is less, because you are initially going to distribute it to regional edge caches, and Amazon is going to distribute it to multiple ones. So faster and fault tolerant. This is an example architecture. If you are able to follow it, great. Say for example, here is your end user. You're trying to browse any website. So you are going to hit an Amazon Route 53, say for example, like cdn.mysite.com, and then it will point to CloudFront, and that CloudFront will point it to the edge location. And if you have any firewall configured, that firewall rules will apply to the URL that you are requesting. Say, as I said, you are from which location, it will try to see whether you are allowed from that location or not, and then reject it or forward it. If it is forwarding, it goes to the regional edge cache that we just now spoke about, and from there it goes and hits the distribution itself. And once it hits the distribution, it says what is my origin, whether my origin is an S3 bucket, or my origin is a load balancer, or is it a custom origin that is sitting inside a corporate data center. So based on that, my distribution will send you the request. So, and again, the request will flow back all the way to you. So this is how a logical architecture for CloudFront looks like. Again, this is not an interview question, or this is not an exam related question, but this is how a background architecture looks like for CloudFront. So you should be aware of that logically. So if to explain to somebody how do you set up a content distribution network, then you can answer that confidently. So let us go ahead and quickly do some demos. We have done a lot of talking. This we have seen yesterday. We are going to see this one today. So are we good, guys? Let us go ahead and do a demo. What do you guys say? Quick yes or no? Here, as you can see, guys, we are in the Valaxy demo access logs bucket, and yesterday we created a lifecycle policy. Let me go ahead and quickly open my management tab, and under lifecycle policies, let me open that. Okay, I have to edit it. Okay, I'm just going to go to the review page where we can see the data here. You can see here we said a transition to Amazon Glacier after 1 day, and then for a current object and the previous objects, and expire them after 3 days and permanently delete them after 5 days. So I'm going to go to my overview here, and you can see these are all the different access logs that was generated over the last couple of days, July 20, and then going all the way to July 21. As you can see here, the ones that was created on July 20 are already in Glacier, and the ones that are created on July 21st is in standard. So it is time is at 8:49. Probably I'm not too sure. Probably another 20-30 minutes. Some of these files also might be moved into Glacier. Probably if we are still here, we can come ahead and check that. So anyway, this is how your lifecycle policies works. Probably if you can remind me after 5 days, we can come back and see that entire directory might be cleaned out, because we have a policy to delete them as well. So moving forward, and we are going to use the Valaxy demo bucket for our static website. I have index.html. What I'm going to do is I'm going to try and upload my index.html. I just made a small change to my index.html. I'm just going to go ahead and upload it. Click next. Click next. I don't want to encrypt it, but I will like to put it in reduced redundancy storage, and then click next, click on upload, and it is showing in progress. It is already uploaded, as you can see here. And I'm just going to make sure that it is public read writable, publicly accessible, not read writable, publicly accessible. So you can see here, everybody will have access to one or all of the following. Read this object and read and write permissions. Make public. That is what you get when you make something public. So I just want to show you what it opens up. Let me just double click this, and this is what all of us should be seeing right now. And I also have a static website. If you remember, we created yesterday. I'm going to give the URL to you guys right now. Static website. Click on this URL. This is a very nice experiment we all can do. If you can open the static website right now, and you should be seeing some page. And if you're in a Chrome browser, it makes it very easy. If you just right click it and say open the image in a new tab, what happens is it opens the image in a new tab. That is not the interesting part of it. You can see there the image is served from my S3 bucket. You can see the prefix as my S3 bucket. Let us see what happens when we set up a CloudFront distribution and try to see where are the images are coming from, whether it is coming from a S3 bucket or it is coming from a local regional edge cache or a cache location. So that is what we are going to demonstrate. And you can see here, as of now, my connection is not secure. Your connection to the site is not secure. In other words, we are using an HTTP connection. So what I'm going to do now is set up a CloudFront. For CloudFront, you go to the CloudFront service. If you don't know where to go, you go to your console. You just type CloudFront here, and then this is the service. Just click on it. It will take you to the CloudFront dashboard page. And as you can see, I have multiple CloudFront distributions, and one of them is already in progress, and it is getting disabled. I'm going to create one for the same bucket right now. I'm going to click on create, and as I told you, there are two options for you. This is the first one, that is web option, is for static websites for distributing media files, HTTPS, and you have another option called RTMP. If you want to use CloudFront to do live streaming or create a web distribution using media files which are streamable, then you use this option. For now, we are going to learn how to do HTTP and HTTPS, that is static website content. Go ahead and click on get started, and then when you it's very straightforward from here onwards. Amazon made it very simple. The moment I click on this, it will show me all the options that I have currently. You can see here we are going to choose our demo bucket. See here, Valaxy demo bucket automatically. And if you don't know what you are going to choose, click on this button. It gives a nice description of what you want to do here and what are the options that you have to choose here. It has a very nice descriptive field and shows you the options. Origin path, again I'm going to say I'm going to take a reference here. It says optional, and if you want to use the CloudFront of multiple locations or a different location, then give that name here. I'm going to leave it empty here, and then leave the origin ID also empty. And it says, do I want to restrict my bucket access? No, I don't want to restrict any bucket access. And do I want to give any custom headers? No. If you want to identify your HTTP request so that in your access logs you can pick it up easily, then you can add this request. So you can have something like a name and then CloudFront request, something like that. And here's where the default caching behavior gets interesting. What I'm going to do is I'm going to force HTTPS only. So almost all the HTTP traffic will be dropped, or what I'm going to do is this also is possible. Redirect all HTTP to HTTPS, and so anybody tries to access my website or CloudFront distribution using HTTP will be automatically redirected to HTTPS. Remember, I said that my current static website is not secure. If you go ahead to a Chrome browser and click on this small icon, it will say that your connection is not secure. So let us see what happens when we start doing HTTPS, redirect HTTP also to HTTPS. So I'm going to allow all the methods, get head, get options. I'm not going to do delete. I'm not going to allow any of you to delete my distribution. So I'm not going to do this. And I'm not going to do all these options. Leave it as it is. Scroll down. There will be one option for setting my route path. That is my route path. Okay, so far we are done. So far we are good. We are in distribution settings now. This is where the place where you want to choose where you want to distribute it, whether you want to distribute it to the western part of the world, whether Asia is there or not. The next one is Asia is included, and this one is includes Australian regions also. So I'm going to choose the western part of the world now. Leave it as it is. I don't have a Route 53, so I'm going to leave it as it is, and see that automatically my CloudFront is picking up the default SSL certificates, which is provided by Amazon, and it is not giving me an option because I don't have my own certificate already generated. If I want to generate it, I'll have to use this option. Let us not try to complicate too many things. Leave it as it is, default. Just don't change anything. Come down, default root object. I'm just going to click on it. It says that if somebody is requesting for www. My root domain, where should I point it to? I wanted to point it to slash index.html. That is my root object. And I want to enable logging. I'm going to click on logging enabled, and I'm going to put it in my demo access logs. Remember, we created an access logs bucket dedicated for logging. I'm going to say put my logs there and put the prefix of demo there and leave everything as it is and click on create distribution. That's all we have to do right now. Fill in all the fields, use the small eye icons at the right hand side, and then you will be able to find out what help you need. And usually it takes about 5 to 10 minutes to deploy. As you can see here, I yesterday created a similar distribution and I have disabled it, and right in front of you I created one more distribution for the same destination, and it is getting cached all across the globe. It is in progress state, and if you click on this one, you will get the status, you will get a summary of all those things. You can see the distribution status is in progress, and this is the domain name that we are going to use to access our website now. I'm going to put it in the chat window. I'm going to wait for some time, and then we will see whether it is propagating or not. I'm going to put it in the browser window as well. It takes some time to distribute it. So until it gets distributed at about 10 minutes, I'm going to quickly cover another topic. You can see here the restrictions. I just opened the distribution. You see restrictions here. What I'm going to do is I'm going to show you how to restrict it. Go to restrictions, click on edit, and it will show you enable geo restriction. I'm going to say yes, enable geo restriction, and it is asking me whether you want to allow people or block people. Let us say I want to block people. That is what the translation of these two means. A blacklist means if you click on here, it will say that blacklist, the countries the countries list contains the countries where you don't want CloudFront to distribute your content. So when you choose blacklist, you are going to block some countries. So what do you guys say? We will blacklist the Indian people or the US people? Quickly, guys, you have to make a choice for me here, because we have. If you have to experiment, one of you has to take a fall here, or anybody is there from a different country. Too bad, huh? 2 votes, 2 against. Is there any votes for against? I'm going to see if I can search. No, it is not working. Okay. I'm going to click on add here, and then that's it. You just go ahead, click on add, and then let me just check whether the distribution has taken into effect already. Not yet. It has not taken into effect. Anyway, what happens is why I'm reluctant to. Is it working, guys, already? Okay, that must be guys in the United States. Rajshekar, are you from the United States? Okay, so I mean that proves it, right? It is starting to distribute the content in the Western world already, and for the caching location in India. Oh, Rajshekar, I am not able to open it. Surprising. Anyway, so are you able to see the HTTPS location? I'm just waiting for it, refreshing. I don't know. It is not working for me so far, at least. Um, so what I'm going to do is, since some of the US folks are already saying that it's working for them, I'm going to restrict their access and let us see what happens. Click on edit. So we have effectively blocked the folk in the United States region to access the content. And again, remember that every change that you make in a distribution, it has to be propagated to all the edge locations. So again, it will go back to in progress state and it will start distributing. So, oh, great, it got blocked. Can you copy paste the text that you're seeing, Mr. Naga? So everybody can see what happens, or the other people can see what happens when you try to access the distribution. Okay, is that private to me? Okay, great. See, guys, if you are able to see the chat window, that is the error message typically you get. So this is how you stop distributing your content, and it is also possible to show a very graceful error message if you go to error pages, and if you can configure create custom error response, you can be a little bit more graceful on the error message that you can say there, instead of giving all that information about request ID blah blah blah, you are being denied. You can say that we are waiting to launch in your country, something like that. We will be launching very soon. It looks a more positive outlook for the error message. So you can do all that using the custom error messages that you have here. And for some reason, I'm still in the underprivileged group. I believe, according to Amazon, I'm not able to see the content at all. Anybody else from India able to see the content? Mr. Naga, are you sure you are using the CloudFront URL and not the static website URL? Can you just confirm that? Rajshekar, I believe. In my experience, it takes about 10 minutes for the distribution to completely work and then show it. Okay, when you say you use the chat window URL, you're talking about that alphanumeric.cloudfront.net, correct? Okay, I'm just going to open it again and then just pray that it works. Nope. I'm underprivileged. Okay guys, I'm just going to wait for it to get into deployed state so that I can access it. Meanwhile, I'm going to take a pause and take questions from you guys. So what we are going to do now is we are going to, I have created two buckets. We are going to see how image resizing happens. Usually it happens through a Lambda function, but since I have not set up the Lambda function, we are going to see it offline. We need two buckets. Ideally, one bucket should be fine, but keeping it separate is easier to manage. So I'm going to have one bucket called process image. That is my source bucket, and my destination is going to be this multi-sized buckets. And I'm going to go to multi-sized, and under multi-sized, I have three options. One is the cover size, one is profile size, and thumbnail size. For now, we are going to create only a cover sized image. As of now, you can see there is something called cover big people, and then the size of it is something like about 10 KB. If I go back to my, oh, great. Okay, let me show that again. There are two buckets in my S3 account. One is the process image, that is my source bucket, where I'm going to upload a big-sized image. Let us say about I mean, when I say size, I'm not talking about the number of MBs. I'm talking about the pixels. Of course, with pixels, sometimes the image size also increases, but not always. So let us say I'm having a very big pixel, the image, and then you have a destination bucket, which is multi-sized images. And if I open here, I have three different subdirectories: cover size, profile size, and thumbnail size. So whenever an upload happens in the process image bucket, automatically it should be picked up and then converted into three different sizes. No, they should come and sit in here. So I'm just going to demonstrate it in a more crude way. Probably in the Lambda classes, I will refine the process. So as of now, let us go ahead and go to process image and let us upload something big here. You can see here there are two files of bigger sizes. Let me just go ahead and upload something from my desktop. Add files. Okay, this is quite a big file. How do I show that? Is there a list option? Okay, if I can show the properties for this file, the DNA page, it is 2.6 MB. Let us go ahead and upload this guy and try to see if we can resize that guy. I'm going to open this guy and I'm going to add one more file also. How do I drag and drop? No. Okay, let us do that later then. No public access. Let us make it reduce redundancy. Click on next, upload it. You can see one is in progress at 2 MB. It depends upon my internet speed. It should take a minute or so. Meanwhile, I'm just going to go ahead and refresh my CloudFront distribution and see if it has happened. That is really, really strange. Why my distribution will not have happened. This is the one. Let me go ahead. That is really strange. Okay, what I'm going to do now is just going to, where is the edit option? I'm just going to revisit here what happened here. Did I blacklist, enable geo restriction? I'm just going to click it on no. No, it should caching. Caching just improves the latency, not restricts it completely. Okay, let it. As you can see here, what happened? Whenever you make a change, Amazon tries to repropagate the change to all over the edge locations. So it takes a while to propagate again. Meanwhile, while this is happening, I'll just refresh again to see any progress. No, not really. This guy is spinning. Oh, yeah, it worked. Probably the geo restriction is not set up properly. That is the case. I need to work on my geo restriction to ensure that it is working properly. As you can see here, the image is loaded properly and then the text has come from, and the URL, as you can see here, Google says that I'm coming from a secure source. And even if I type this one directly, that is HTTP, it should make it HTTP. Automatically, I should be redirected to HTTPS, as you can see here in the top. And if you click on that, it will say that you are using a very secure connection, blah, blah, blah. And you can use SSL labs to test whether your connection is secure or not. Let me just right click and open the image in a new tab. And you see that the image is being delivered from my edge location and not from my S3 bucket. So this is how Amazon achieves a low latency and faster data delivery to the customers. Whereas if I go to my bucket, you can see that in my bucket, when I open the image, the bucket image is delivered from my bucket. And if I go to my content distribution and right click and try to open my image, and you can see that the image is coming from my distribution, and the image is distributed in a secure way. So without much cost, without much expenditure, we have set up a static website, and we have set it up as HTTPS also. And if we set it up properly, we can set up the geo restrictions as well to work accordingly. So that is how content distribution works. And most probably you guys will be working on setting up content distribution as a configuration where you will not be working on setting the HTML page and all those things. So we have that is about content distribution. Let me go back to our other demo of doing the image resizing. You can see here dna.jpg is been uploaded. I'm just going to copy the name so that I can use it in my code. Unfortunately, the code is a little bit of hard coding and all those nonsense are there, so I'm not even sure whether it will work, but I'm going to just check whether it is going to work. If it is not going to work, guys, my apologies. I spoke prematurely. Here what I'm going to do is I'm going to run Python lambda image resizer, and what basically does is it goes and connects to my S3 bucket, downloads that image to my local computer, resizes it, and uploads it to the cover.jpg. And my temp file, if I go there, cd/temp ls-lrt, I should be able to see something like a resized.dna.jpg. This is the same file that has been uploaded to the cloud. Let us go to the S3 bucket, cloud. Where is my S3 bucket which says multi-sized images? And if I go to cover size, we should be able to see. Oh, interesting. My upload did not work. Okay, yeah, I refreshed it. As you can see, guys, here we have a cover DNA page. I'm going to see here the size of it is 6.3 KB, and let us make it publicly accessible so you guys also can see it. Okay, it just jumped off. Where is the chat window? If I put it here, is it downloading again? Yeah, it is downloading again. You can see, if you can see here, that image has been resized to a very small one, whereas it was a 2 MB image initially, and now we have a very tiny image right now. So that is how typically Facebook or Google or anybody, whenever you upload an image, they create a profile image for you, they create a mobile sized image for you, they create a tablet sized image for you. This is how it happens in the background. They automatically run some process, that is a Lambda process or some kind of containerized process, and those process pick up the any uploads. Remember, we triggered an email notification yesterday. Instead of an email notification, we will trigger a Lambda notification now, and that Lambda notification will go ahead and download this image and process it and re-upload it. So just to show it once again, yeah, images are not shown as a browser objects. Like, it is not an HTML page that you can browse it, so it will download it for you guys. The browser will download for you. That is how Amazon S3 also forces it. So you can see here, it is an 6.3 KB, 6.7 KB. If I go to my original bucket, which is process images, you can see here dna.jpg is actually a 2.7 MB image, and that is how the image resizing works. So that's it.